Okay, today in geometry we'll do Notes 5, measure and classify angles. This is an easy assignment today. Make sure you put your name, date, and class period, please. Our essential question for today is, how do you identify whether an angle is acute, right, obtuse, or straight? Should be easy to answer. Okay, we have two postulates. Remember, a postulate is just a rule that they just made. The first one was how to explain how to use a protractor. It just states that the measure of angles equal absolute values, so they're always going to be positive between real numbers, so they're always going to be positive. So make sure you always have positive degrees. But the essential one that's very, very important is postulate 4 is kind of like postulate 2. Very, very similar, because postulate 2 was segments addition, 4 is angle addition postulate. So this is kind of the same situation as we've had on segments, but this one's on angles. So if you want a little picture that goes with this one, I have a large angle that almost looks like a right angle, but it's not. But I have an angle that is an R, the vertex is an S, and I have another part down here that is a T. But I also must have another ray in the center of it that has a P option. So this is saying that RSP, so this angle here, plus this bottom angle PST, which is here. So I have my little angle on top, my little angle on bottom. Says that if I add those two angles together, I will get the angle of the large angle. That is this one that I wrote in red. So this is like the little angle plus a little angle equals the big angle. Just like the segment addition postulate, this is the angle addition postulate. Very, very important. Okay, on example 1, it says we want to write 3 names for an angle and name the vertex and the sides of the angle. So there are like 3 answers, 4, 5, 6. There's 6 answers on this problem. So if I zoom in here, and we want to first write the 3 names. Well, on an angle, remember that the center point happens to be the vertex. So R is going to represent my vertex. And then I have 2 rays that come off of it, which represents my side. So I'll have side RJ and side RM. So I can first state this statement that I just have. Vertex is R. The sides are going to be RJ, but I need the ray symbol, as well as RM, and I need the ray symbol as well. Make sure you start with R because that is the vertex and that's where it's coming from. Then I need to name the angles. I need to name the angle 3 ways. Well, I'm going to start with the angle symbol, which looks like cursive L. A lot of times I will actually draw a little arc through it to emphasize that this is an angle. And then what I do to name it, I'm going to name the 3 points. And to do so, I need to name part of the ray first. So I'm going to do JRM. Or I could do the reversal of this, which would be angle MRJ. But what is very, 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 very important is to know that on either one of these, the R is in the center, which symbolizes the vertex. It must be in the center. The third way of naming this angle, when it is just in this fashion, is to say angle R, which you name it according to the vertex. Alright, there are 6 types, or 6 answers for number 1. On number 2, you got to have your protractor, because it says, okay, use a protractor to find the measure of the given angle. And then they want you to classify it as either being acute, obtuse, right, or straight. Remember, acute is an angle that is less than 90 degrees. Obtuse is the opposite of that, an angle that is greater than 90 degrees. A right angle is equal to 90 degrees, and then a straight angle is equal to 180. If you need to write those down, make sure you do so. At least you can put it in the column over here. Less than 90, obtuse, greater than 90. A right equals 90. Realize obtuse is greater than 90 but also less than 180. It cannot go over 180. And then a straight will equal 180. Alright, so if I go to my first angle, this is angle AFB, I'm going to put the center of my compass at the point F. Make sure the edge of your protractor lines up on, or the line on your protractor lines up on the ray or the line AE. And then I'm going to go from AFB, which this is the closest side, which means I'm looking at this. I got to go from the 0, means I'm on the outside of my protractor. If I measure it around, I can't quite see that. Let me get a paper. Line it up like we did with our constructions. And see that this measures 54 degrees. Now realize, you have two numbers on your protractor. You have an inside scale and an outside scale. If I'm looking at this, this is either showing to be 54 degrees or this is showing to be 126. And if I'm looking at this angle here, come on, use some common sense. 54 degrees and 126 degrees look totally different. One's acute and one's obtuse. Use some common sense. So the measure of this angle, which I'm going to put an M in front of it for measure. I'm kind of cheating. Maybe I shouldn't do that. The measure of angle AFB is equal to 54 degrees. Notice my notation. The M in front means the measure. Like up here. Let me show it to you. I didn't emphasize that earlier. It has the measure of the angle RST equals the measure of RSP. So that M represents the measure. That's actually a number, and that's why we can put equals. Alright, so we have it 54 degrees. So is it acute, obtuse, right, or straight? Well, 54 is actually less than 90 degrees, so that means this has to be acute. Alright, if I go back to my picture, and now for the second one, it has BFD. BFD. BFD is inside, it's not even on the line AFE. So I'm going to line my protractor up along FD on the bottom and FB up through the protractor, and this one is a nice one because it shows to be, if I look at it right, from here to here shows to be actually 90 degrees. Okay, so the measure of angle BFD equals 90 degrees, which is what kind of an angle? Okay, that is a right angle. I forgot to put angle on the other one. Alright, looking at the third example, AFC. If I go back to my protractor, let me turn this sideways finally. I'm going to line it up, put your center point at F. The edge of your protractor is along the bottom of your protractor's line. And then AFC, if I'm looking at it, I get in the right spot. That's really close to my value. Let me slide that. Let me make sure. AFC, so I'm measuring off of FC to C. Looks not quite 110. Looks like it's slightly below. I'm going to say 109 for this angle. And let me put a little mark on here. From here to here, I'm saying is 109. Oops, 9 degrees. I'm going to say the measure of angle AFC equals 109 degrees. Alright, classify it. If it's 109 degrees, is it acute, obtuse, right, or straight? That would be obtuse. That is an obtuse angle. I'm using the angle symbol for my naming. Okay, and then the last angle on this example is AFE. which well, I don't even need my protractor for that, because AFE is this angle, which is a straight line, which has to measure 180 degrees. So I know that the measure of AFE equals 180. If it's 180 degrees, means it is called a straight angle. Alright, page 2. Or on the back of your paper. Example 3. It says, find the indicated angle measure. Alright, so we're going to be looking for the measure of RJM. RJM. Then, classify the angle as being acute, obtuse, right, or straight. If I look at my picture, RJM is what I'm looking for. I'm going to highlight it. They give me two parts. They give me the first part is 35 and then the second part is 90. So using postulate 4, that's my angle addition postulate, I'm going to say I'm going to take the measure of angle JRN. I'm going to add to it the measure of angle NRM, and it's going to give me the measure of my angle JRM. This is what I'm thinking. This is my thinking stuff. So plug it in. That'd be 35 plus 90. Oh, my nose is itching, sorry. That means the measure of angle JRM is equal to 125 degrees, if I did that correct in my head. Here's my first answer. Then, is it acute, obtuse, right, or straight? Well, 125 means it is obtuse. And there's my answer. Okay, so either highlight it or circle your answer, whichever you have. Example 4 is an algebraic type of problem, doing kind of the same thing we did at example 3, just making it a little more difficult. It says use the given information to find the indicated angle. I'm asked to find the angle ADB. So I'm going to highlight that little piece because that's what I'm looking for. They do tell me that ADC, which is the entire angle, that entire angle is 118 degrees. I know by the angle addition postulate that angle ADC is going to equal angle ADB plus angle BDC. So I know this big angle is going to equal the two little angles. If I fill it in, ADC is 118. ADB is 11x minus 7 plus BDC, which is 5x minus 3. Let's combine like terms. 11x and 5x is now 16x. Negative 7 and a negative 3 is now a negative 10. This is a two-step equation. I'm going to add 10. That gives me 128 is equal to 16x. And the last step is to divide. 128 divided by 128 divided by 16 tells me this is 8. Now this is my x value. It's asking for the little angle here on top. So I'm going to take my 8. I'm going to do 11 times 8 minus 7. Well, that's going to be 88 minus 7, which is 81. To write this correctly, the measure of angle ADB equals 81 degrees. There is my answer. Okay, I'm going to highlight it. Okay, here is your independent practice problem. And it says, in the diagram, BD bisects. Bisects is a very important word. I'm going to highlight that puppy. Bisects this large angle. We want to find ABC. So your ultimate goal is to find this large angle here. But you've got to know, what does that word mean it is doing to this angle. Alright, I want you to work it, and we'll check to see if you have the right answer. Okay, working this problem out, I came out with the measure of angle ABC equaling 118 degrees. So if you got this correct, this time let's give yourself a thumbs up if you got it right. That'll be a good job. Way to go. You got a thumbs up, or you can draw a smiley face, whichever you like. Okay, so make sure you answer your summaries for when I pick up your notes. You'll get 100 if you have your summary completed and all this written. Alright, thank you.